ID number must be 13 characters long. Once users entered all the details, they're able to click register. The first name must not contain a character, a number, as well as the surname. The email must contain an @ will not be saved. The password and username must contain at least one capital letter and a number. Once the user successfully registers, it takes them to the customer login page. I will now be demonstrating how the customer login feature works, and I'll be using the data that was inputted in the customer register page. First, the user must enter their username and their password, but if their password is incorrect, it will display an error, such as invalid username or password. Same with the username. So if the password is correct, and then the username is incorrect, it will display an error, the same error. So now, if both inputs are correct, it will then log the user into the customer dashboard or into the application. My name is Aiden, and I'll be demonstrating the register and login functions of our banking portal. So how the register works is that when the data is inputted, it validates each input, such as the first name, email, username, and ID number. If any of the validations or like any of the inputs are incorrectly formatted, it displays an error to the user. And then once the inputs pass the validation, a random account number is generated. A SALT is created with B. My name is Aiden, and I'll now be talking about the backend for the login. To ensure that our login is secure, we have implemented Express Brute. Express Brute limits the amount of times a user can attempt to log in. So after a certain amount of inputs by a user or attempts to log in, the user will be blocked. How the login functions is first, the database checks for a user with a given username. If the user is not found, it responds with an invalid username or password. If the user is found, it compares the entered password with the password that is connected to the user that has been found in the database. If they do not match, the user is then displayed with an error that says invalid username or password. Once the username and password has been correctly inputted and there's no errors, the login then generates a token for the user.
Hi, my name is Mikayle Turner. Upon logging in, the user will be greeted by the dashboard. Here, the username is displayed. In this case, it's Mike Taylor. The user can also click one of the buttons to make either a local payment or an international payment. User bank details such as their account type, account number, and available balance will be displayed here. One of our extra features is this card. You can see the Swift banking card, the account type, the name of the account holder, the account number, and its available balance on this card. Below the card, you can see the payment receipts. Here, you can see all the payments that the user has made, as well as the history of them, such as the date, the recipient name, recipient bank, amount, SWIFT code, and transaction status. This will allow the user to keep track and manage their transactions. On the left, you can see the menu bar. Here, the user can use the menu bar to navigate to the various points within the app, such as transactions, local payments, deposit, and international payments. When the user navigates to the transactions, they will see their transaction history. This will display in the format of a table. including the date, recipient name, recipient bank, amount, and SWIFT code. To make a transaction, the user must first add funds. When the user adds funds, they act like a deposit. The deposit will allow the user to add funds to their account in case that they can't reach an ATM. This is for test purposes, as in reality, this would be a big disadvantage to allow users to enter funds like this, but this is necessary for our testing. And to be able to simulate payments properly, the users must have an amount in their bank. Payments can be made by either clicking Make a Local Payment or Make an International Payment. Once one is clicked, the user must enter the details. If the details are entered incorrectly, or if the details are invalid, the user will not be able to proceed and click pay when they pay now. If the user wishes to, they can click Cancel at any time to return to the dashboard. The user must enter a recipient name, recipient bank, which are not checked, as this will be checked by employees, as well as be checked when connected to the SWIFT network. Without access to the SWIFT network, the users would not be able to make interbank trades or exchanges. So therefore, this is a necessary part and would need access to the other banks on the SWIFT banking pipeline. Furthermore, when the user sets the amount to transfer and enters and clicks Pay Now, the amount is deducted from their bank account and the transaction is then pending. This means that it is waiting confirmation from a banking employee. You can see that inside the database, the various transactions, as well as the users, along with their correlating IDs, are all stored. It is very important that when users are stored and accounts are stored, that they are correlated using the user ID. The account number is also correlated here.
Hello everyone, my name is Mikayle. Today I will walk you through the CI/CD pipeline configuration for our React project using GitHub Actions. This pipeline automates building, testing, and securing the project to ensure everything runs smoothly before deployment. The pipeline has two trigger events, one of them for when the code is pushed to the main and the other for when the main branch is pulled. This ensures that every change is made to the main branch, whether directly or through a pull request, is automatically tested and built. Next, in the job section, we define a single job called build. This job will run on the Ubuntu latest environment, which provides a clean virtual machine for every pipeline execution. Within the service block, I also started MongoDB instance version 4.4 because the project requires a database. The service is mapped on port 27017 so it can be accessed during the pipeline run. For the Node.js section, I've set up a matrix with two node versions, 16 and 18. This ensures that the project is built and tested in both environments, giving us confidence that the project can work across different versions and Node.js. So let's go through the steps of the pipeline. First, we use action checkout to clone the repository into the runner's workspace to ensure that the latest code is available for all steps. Next, we use action setup node to install Node.js version 18, which is required for the project. Then I navigate to the backend directory and run npm install and install all backend dependencies. After that, we fix the permissions for the node modules folder, especially necessary when working with Linux-based systems like Ubuntu. At step 5, I make sure that the React scripts binary has the necessary execution permissions. This is to avoid any permission errors while running scripts. After that, we installed front-end dependencies. The legacy peer deps flag is used to ensure compatibility with older dependencies in the project. And just to be safe, I explicitly installed React scripts with npm install React script legacy dependencies in case it wasn't installed earlier. At step 8, we then checked whether the SSL certificates are present in the backend. If the SSL certificate or key is missing, the pipeline will fail, ensuring secure HTTPS connections. For step 9, we installed HTTPy, a command line tool for making API requests, which is useful for testing the backend. Next, we started the backend server in the background and waited 5 seconds to ensure that it is up before proceeding. This allowed the server to be available for tests and further checks. For step 11, I ran various security checks in the backend. We check for Helmet's FrameGuard middleware to protect against click-tracking attacks. We look for session management libraries like cookie sessions and express sessions. This checks the parameterized queries in the database layer to prevent SQL injection. We verify the HTTP strict transport security is enforced using Helmet. Finally, I check if the express rate limit middleware to prevent DDoS attacks by limiting request rates. Lastly, if the pipeline encounters any failures, I upload the test results. This helps with debugging by preserving logs and error details.